Brianna is considering buying an electric vehicle from Zapra Motors. The manufacturer claims that, on average, a driver will be able to travel 350 kilometers before needing to recharge the vehicle, and the probability of travelling more than 400 kilometers before needing to recharge is 0.2525. Let x denote the distance in kilometers that a Zapra Motors vehicle will travel before needing to recharge. Assume that x is a normally distributed random variable. So the first thing we want to do is determine the standard deviation of x. So we've got the mean here as being 350, and we can use this 400 together with a standard normal. So if we have the standard normal, which remember is a normal 0, 1, and we have 0.2525 down here, gives us this value here is 0.6666, as we can see there, and then we can use that as a z-score. So 0.6666 is equal to 400, which remember was the value on our distribution, take away 350, which is the mean, divided by the standard deviation, and solving that gives you that sigma is 75 kilometers. Brianna will need to travel regularly to Albany, which is 420 kilometers from her house. Calculate the probability that on any given day she will be able to drive to Albany without recharging the vehicle. So we can use the normal distribution 350 75 squared and then just do the probability that x is greater than 420, which is 0.1753, a value we're going to need later in the question. That's just standard normal CDF stuff, so there's no need for me to show you that. Matthew is interested in buying the same type of electric vehicle, but as he lives in England, he would like to consider distances in miles. 1 mile is 1.6 kilometers. Let y be the random variable that denotes the distance in miles that a Zapra Motors vehicle will travel before needing to recharge. Determine the expected value and variance of y. So y is going to be 1 over 1.6x. So dividing by the 1.6 to go to miles. So the expectation of y is going to be 1 over 1.6 times the expectation of x, which is 350 divided by 1.6, and so that gives me 218.75 miles. And then for the variance of y is going to be 1 over 1.6 squared times the variance of x, which is 75 over 1.6 squared, giving us 2197 miles squared. And if we want the standard deviation, we would just take the square root. Brianna decides to consider an electric vehicle from a rival company, Spruky Cars, that show her the histogram below based on 200 trials of its electric vehicle. Let W be a random variable that denotes the distance in kilometers that a Spruky Cars vehicle would travel before needing to recharge. On the basis of the histogram, is it appropriate to use a normal distribution to model the distance a Spruky Cars vehicle will travel between recharges? Justify your answer. Well, no. The distribution is skewed or not symmetric. Would do for that one. Assuming the distances are uniformly distributed within each interval, use the histogram to estimate the expected distance that a spruiky car's vehicle will be able to travel before needing to recharge. Okay, so the midpoint of this interval is 270, and we can see that that is 4 out of, how many did they say? I think it's 200 vehicles. Yeah, 200 vehicles. So we are going to have the expectation of W is going to be 270 times 4 over 200. And then we're just going to go to the next interval where the midpoint is 290, and we can see that that is 8 over 200. So that would be 290 times 8 over 200. And then we're just going to carry on with that all the way across. We can see the last one here. That is going to be 430, and it is 20 out of 200. So we've got 430 times 20 over 200. If you do all of that and calculate it, it's a lot of work actually for a couple of marks. It's going to be 375.8 kilometers. And then it continues on to the next page. I love 3-page questions. In which company's vehicle, Zapra or Spruky, would Brianna be more likely to drive to Albany without recharging? Well, that's where it comes back to what we calculated before with a 0.1753. That was for the Zapra vehicle, 0.1753. For this vehicle to go the distance required, which is 420, that is just our 20 out of 200, which is 0.1. For Spruky it's 0.1, and therefore we can conclude she's better off in a Zapra.